So the topic which I will discuss here, it is related to modulation technique and symbols, mostly onto the symbols. What is symbols in LT, and how that symbol is interrelated with the modulation technique. Okay, so let me start. So what are the modulation technique we do use in LT modulation? Modulation technique. What we use in LT, generally QPSK, 16 QAM, 64 QAM, and in advanced LT we have 256 QAM as well, right? So probably all we the BTech graduates, everybody knows what is QAM. It is quadrature phase shift keying. Okay, 16 QAM, 64 QAM, and 256 QAM. This is the upper version of it. Okay, so this is modulation technique, whatever we are using. And so how modulation technique, in case of modulation technique, in case of QPSK, how many bits we are getting? So how to calculate that? QPSK means the four octet, right? So if we'll take this, let me pen, okay. Draw. So for QPSK, we have 4 octet, right? So like that, 4 means 2 to the power 2. This is QPSK, right? In case of 16 QAM, it is 2 to the power 4. 2 to the power 6 in case of 64 QAM. Right? So how this is calculated? And QPSK in case of 2 to the power 2, 2 to the power 2 means 2 bits in case of QPSK. So that means 2 bits. Now let me go right. It is 2 bits per symbol. So let me write here. It is 4 bit per symbol, and it is 6 bits per symbol. Okay, so now question is, what is symbol? So this is the topic actually. What is symbol and how we can map that bits inside the symbol? This is actual topic today we will discuss. Okay, so for that reason we need to know what is, you already may heard that LT frame structure. LT frame structure is 10 milliseconds frame structure. We have 10 milliseconds frame structure in LT. If you all know, then really it is a very common topic. You already know. So 10 millisecond frame structure, we have 10 millisecond in T. Right? 1, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let me remove this extra. Okay. So 10 millisecond frame structure. So this is one frame in LT. In one frame is 10 millisecond long. Okay. So, and it is divided into 10 subframes. So this is one subframe. So let me write down the nomenclature. It starts from 1 to 9, 0 to 9. right? So every frame, so let me take one frame, so 0. So this frame, okay, let me take this frame. This frame is actually subdivided in 0.5 millisecond, one part and another part. So this both are called, so this is whole, it is called one subframe. Okay, and so that is 1 millisecond subframe. 1 millisecond subframe. This is complete. Okay, and this is called subframe, and 0.5 millisecond, this part is single part is called one slot, another part is called another slot. So we have 20 slots in 10 millisecond subframes, right? 20 slots, or maybe we can say 10 subframes. 10 subframes. So now this one whole set of uh sorry, this color, one set of 1 millisecond of subframe is being also called one scheduling block. Okay, what is scheduling block then? Scheduling block is actually consist of 12 subcarriers in the 12 subcarriers. So 12 subcarriers means it is into the frequency domain, and there will be 14 WebDM symbols that is onto the time domain. So let me draw that. Okay. Just hold on. Let me a new page. Okay. So let me write down this way. So this is your time axis. This is your frequency axis, right? So you have 10 millisecond frame. So this is all total in time axis. It is 10 millisecond. Okay. One frame. And this F actually F actually depends upon your bandwidth, whatever the bandwidth you are using. So we have different kind of bandwidth in LTE, right? Bandwidth are like 1.4 megahertz, right? 3 megahertz, 5 megahertz, 10 megahertz, 15 megahertz, 20 megahertz. So once we will start training, we will let you know. So it is also having some resource block. Okay. So resource block calculation is there, so that I will teach you some other day regarding during training time. So right now I will just let you know the 1.4 megahertz is having six resource block. So 3 is having 15 resource block. Okay, in case of 5, it is having 25 resource block. Pardon for my handwriting. I'm extremely sorry about this. 50 for 10, 75 in case of 15 megahertz, and 100 in case of 20 megahertz bandwidth. So suppose we are using here 20 megahertz of bandwidth. Okay, so in case of 20 megahertz bandwidth, so it will be total bandwidth, it will be like there, so it will be like 100 PRBs, right? So that is 6 RBs PRB, physical resource block. Okay, so suppose this is how it is actually frequency, means frequency f axis actually. So that frequency axis is actually 100 PRBs for 20 megahertz band. And now so what I will I have already told you that one radio subframe is having like suppose this one. Okay, so this one, let me tell you. So this particular one is your one scheduling block, as I told you, right? One resource block, sorry, one scheduling block, or maybe one subframe. Okay, so this is a completely one is your one scheduling block. And as I already told you that we have 0.5 millisecond of one slot. So this is one slot, 0.5 millisecond of slot. This is one resource block. So one SB equals to 2 RB. One scheduling block, scheduling block equal to 2 resource block actually. Okay. So now we will discuss about the scheduling block. So how the scheduling block, and inside that symbol, this is what we have the topic. Okay, so let me draw that one scheduling block. So this one we will discuss. Let me blockade this one. So this one we will discuss only this block. Okay. Now, so this is 1 millisecond, as I told you. This one block, because it's totally 10 milliseconds. So one millisecond, one subframe actually. So this one we will draw here. Okay. So this is how comprised with, it is comprised with 14 WebDM symbol and 12 subcarriers. 14 WebDM symbol, that is onto the time domain. This is T, this is F. Okay, in case of frequency domain, it is having 12 subcarriers. So let me draw down the 12 subcarriers first. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me make it big. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 subcarriers in frequency domain we have. And next is 14 WebDM symbol. So 14 WebDM symbol in time domain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 and 14. 13 and 14. Okay, so this is your complete scheduling block, which is having 12 subcarriers in frequency domain, 12 subcarriers, and it is having 14 WebDM symbols. In time domain. Okay, so this is here also, you can see we have one SB scheduling block is having 1, 2, 3, 4, 5, 6, 7. So total here 1, 2, 3, 4, 5, 6, 7. So total here it is actually been one resource block. This is one resource block, another one is another resource block, but it is completely one scheduling block. So inside one resource block, so this one is your symbol. So let me draw this with some other color. Okay, so this one is your symbol. This one is your one symbol. This one is your one symbol. Okay, so suppose this one I have colored different because of understanding. I will let you know why I have color different. This is one symbol. This one is another symbol. Okay. So, and another color I will take. Just this is your one symbol. One more symbol. This one is your one more symbol. Okay. So remember one thing. You will not be able to use all the symbols here inside one scheduling block, because there might be some other control channels will be there that will be like then like so it will be used for your signaling purpose. So just to understand just to understand these things, I will let you know. So why this YOLO means, this YOLO is something like that, as we already discussed, right? Like we have QPSK, we have QPSK, we have 16 QAM, we have 64 QAM, like that, right? So in case of QPSK, it's 2-bit per symbol. That means this is one symbol, right? That red one. So red one, the one symbol means, so one symbol is having 2 bits. So this 2-bit in this box is small box. This one so small box is one symbol. So this symbol is consist of 2 bits. Similar to that, suppose that blue one is your 16 QAM. So it will consist of 4 bits. So that one blue box will consist of 4 bits. Okay, so data rate will be high a little bit than QPSK 216 QAM. And again, if you consider the YOLO box, which is your 64 QAM, so 64 QAM means is your 6-bit. So yeah, 6-bit. So 6-bit means, so this consists of 6 bits. So that means the data rate will be a little bit more high than the 16 QAM. Okay, so in another lecture, we will definitely show you when and what time the QPSK and 16 QAM and 64 QAM, this has been actually this has been segregated, or maybe this has been taken by the network. Why it has been sent like that? Because a little bit idea, let me tell you. Suppose this is your inode B. Okay, and let me draw a vibrant color. This is your inode B. Okay, and here is one UV. Here is another UV, and here is another UV. Okay, so this UV is far from that inode B location, right? This UV, this UV is very close. This is 1, this is 2, this is 3. So UV1 is closer than compared to 2 and 3. 2 is in middle of the distance. Okay, and 3 is far away from the inode B. But all the UVs is trying to contact to that this node. Okay, all the UV is trying to contact this node. So EV, so definitely, we will try to give them all the resources so that that EV can contact, you can be connected. Okay, so what happened? So QPSK, it is most robust. Okay, so QPSK will be most robust. So whenever we are talking about these things, so this modulation technique will be provided. So this is actually been what to say, this is actually been decided by the network. Sorry. So the network decided that it will be providing QPSK modulation technique towards this EV, and this is a little bit good, but not the best. So it will transfer 16 QAM. Okay, so it will consider 4 bits per symbol, and this is the best towards the RF means it is nearby. So RF condition is much better than this two. So it will considered as 64 QAM by the network. So it will be given 6 bits per symbol. So this is how it has been calculated, and this is how actually that symbol and bits relation with respect to the modulation technique. So this is one technique. Modulation technique is the one part which is regarding to the LT throughput calculation. So once we will start LT throughput calculation, it will take more than one session, means it will be more than 1.5 hour job to give a session regarding the LT throughput session. So LT throughput calculation, in that time we will come to know the few more topics like bandwidth, like what we have discussed. So inside the bandwidth we have the resource block, how many resource block, and how to calculate this thing, what is the actual resource block, and how much 10% of deduction, and why all these things 20% deduction, and why all these things. Next topic we will discuss like SNR, CQI, MCS. Okay, so this why important all these things. Okay, so then bit rate, these are the most important part. Then duplex techniques like FDD or TD, that is okay, we will discuss anything. Another most important thing is MIMO. So in case of throughput calculation, or maybe the throughput, LTE throughput, to getting the good throughput, and the one more important thing is MIMO. So we will discuss all these things when we will start studying. But this session was only for the modulation technique with respect to symbol, and how that bits calculation and bits actually been mapped inside the symbols. So this is what actually the theoretical session. I will come with another one more session regarding one log analysis. Whatever we are confident, like we are using 100 megahertz, right, or maybe 20 megahertz of bandwidth. Okay, 100 megahertz in 5G. So how it looks like whenever we are taking logs from UE. So whether UE is getting the full bandwidth or not, that we will check. We will check one more test cases also that I will see. I will show you. So this is for today.